If you work around metals, you've probably heard the term passivation more than once. It's a very important process for protecting our metal parts, but what is it and how does it work? Stick around because today we're going to be exploring passivation and the main ideas you need to understand the process. Passivation is a process that we put our metal parts through to make them passive or less reactive to its environment to keep it from corroding because nobody wants a corroded part. During the passivation process, we react the surface of the metal with something to form a protective layer. Now, passivated parts generally have a longer service life, and with its enhanced corrosion resistance, the need for frequent maintenance and repairs is minimized, saving time and costs. Plus, it also improves the metal's resistance to harsh chemicals, making them suitable for the use in chemical processing, marine, or other demanding environments. Now, it's important to know that many industries have strict requirements for the corrosion resistance and cleanliness, and passivation helps meet those standards. For example, ASTM A967, which discusses the requirements for stainless steel passivation. So what's actually going on when we passivate a part? Well, that depends on the metal you're treating because the chemistry that occurs on the surface is going to be different. Keep in mind that passivation is a broad term that is applied across many materials. For example, you may have heard of chromium conversion coating and anodizing of aluminum alloys. Those are both forms of passivation. In the case of conversion coatings, we react the aluminum with hexavalent chromium. This forms trivalent chromium and aluminum ions, which then react with hydroxides that condense and form a very thin coating on the surface. During the anodization process, the aluminum part is used as the anode in an electrolytic solution. By passing current through it, the aluminum is oxidized, and a layer of this oxide is formed on the surface. The properties of that layer can then be tuned by adjusting the current or by changing the composition of that electrolytic solution. Lots of different types of metals can be passivated though, like ferrous materials, i.e. those that contain iron. One common form of this is called phosphating, which creates a thin layer of iron, zinc, or manganese phosphates on the surface of the part to provide protection. This can also be used on other metals too. In any passivation process though, the first step should always be cleaning. We need to make sure that we do not have any contamination on the surface, which can act as a barrier to those chemical reactions that we just talked about. Alright, if you like that content, make sure to hit the like button. You can also click subscribe to be notified of future videos. Also, if you have any questions about the passivation of specific metals, make sure to leave them in the comments below or send an email to AskDrAdam@KYZEN.com. Thanks again and stay clean.